Code refactoring would probably not be the art that it is today. We'd have a lot more trouble refactoring code. But that's what DBAs have to put up with. So just take a moment, please take this away. Tell your colleagues, tell your DBAs, because one day, one of them, I hope, will tell me this again. Okay, so on to the more important and significant reasons. You've got to coordinate database change with the changes to your applications. Your database provides an API. That's really the whole point, you know. It doesn't exist in isolation, it's there to work with your application. If you're changing the database, you're almost certainly changing the API. So if you're changing the API, well, your applications have to change. And you may have many applications. You might have a web front end, you might have some web-based control system, you might have some reporting tools, you might have extract, transform, and load functions. All of those potentially are going to change when you change the database. So you've got to coordinate this stuff. You're probably going to have to update the database at the same time as you update your applications. If you don't, well, you're going to have to provide a backward compatibility API. This is the sort of thing that we quite often do. We'll say, okay, well, we're going to change table X to be table Y, but we'll create a view that makes it look like table X. So we don't need to change the applications at the same time. So we roll out our database change. At some point, we update the applications. We deprecate the old backward compatibility API, and then we finally drop it. Well, in 20 years of doing this, I've never seen us get to the stage where we drop that old API. So you do the backward compatibility thing, and it stays there. It's just more stuff in the database, more stuff to manage, more stuff to manage in CVS where you don't actually have the source code. So it's an issue. Probably more significant is this one. Databases have inertia. Well, what do I mean? Inertia is the property of something to continue in uniform motion unless an external force is applied. The more inertia, the more force you're going to have to apply to change the direction. And databases have data. That's kind of the point. If you've got a change that's going to lock a table, it's going to take some time. If it's a 20 megabyte table, it might take 2 seconds, no problem. If it's a 20 gigabyte table, well, it might take a couple of minutes. If it's 500 gig, well, you're in trouble. If you've got a 24/7 system and you're trying to make a change like that, you're going to have an outage. And that's significant. So you're going to have to arrange for downtime. 24/7, it'll probably be in antisocial hours. And remember, you're going to do this at the same time as your application, so you're going to be bringing in not just the DBA, but your application guys. So they're all going to be up at 4 in the morning. And of course, you're going to want a rollback process, because it could go wrong. It could take longer than your outage window allows. But in spite of everything you do, it may fail. And if it does, and you're not using a database with transactional DDL, your rollback script may not succeed either. So there you are at 4 in the morning, everyone's tired, everyone's grumpy, and you've got to deal with this failure. It's not a happy situation. I've been there. We had a fairly simple upgrade, 4 or 5 steps. It was going to take about a minute to run, so we didn't arrange downtime. And what happened was, about the 3rd step, there was an update table, whatever, and it had to do a locks table. Well, Oracle decides that if you can't get the lock straight away, it will just fail. And we had a report running and couldn't get the lock running straight away, so it failed. Went on to the 4th and 5th steps, which succeeded, and now we've got the database in this really strange, unexpected state. I had a rollback script, it was no damn use. So that, it's the sort of thing that happens. The more data in your database, the more it's going to resist change. So it's a problem. And the last reason is that, well, you've got a lot of databases. You don't just have one. It's not just one production database. You've got development databases. You've got QA databases. You probably have a staging database. You may have one or more production databases. And each database potentially may be in a different state. And comparing state databases isn't the easiest thing. You can't just run your subversion tool and say, what version are you at? It doesn't work that way because you don't have the source code. So in development, what's going to happen is developers are going to apply this patch, they're going to apply this patch, and so on. And of course, some patches probably should be rolled back and reinstalled, but that never really quite happens. So your development databases are always in a slightly strange state. But of course, that's where you build your script to create the patch for QA. And so you're building a script in a place where the state is different from your target state. So the QA database, well, okay, we run patch 1 and it works, we run patch 2 and it works, we run patch 3. Well, okay, maybe it doesn't work, but we're okay because we're using Postgres and transaction DDL. We don't worry about that. We run patch 4 and patch 5 and they're good. But then we discover that the change for patch 4 can't be rolled out because the application's wrong as well. So now we've got patches 1, 2, 3, and 5 that we're going to release to production. Well, guess what? Patch 5 may have had a dependency on patch 4. You don't know. It's a real problem because we don't have source code. We don't have source. And it gets worse because if you're dealing with replication, you've now got more than one production database. And so you've got even more interdependencies. You might have to even take more outages. Your DBA might be up at 4 in the morning, 3 days running. And believe me, DBAs don't like doing that. And you can very rarely safely automate this. Yeah. However good you get at writing scripts, you can't predict everything. You can't guarantee that you can successfully automate it. So, I hope that I've convinced you that database refactoring is expensive and for a number of fairly well-defined reasons. But so what? Well, if refactoring is expensive, we just cannot use refactoring as a tool for development. So we can't discover the appropriate design by a process of continual refinement. The process of evolutionary design is undermined. It's undermined economically. So our normal approach of doing this is just not appropriate. So we've either got to abandon continual refactoring. Well, that's not that desirable. Or we've got to find less expensive ways to refactor. I hope I'm convincing people. So, let's have a look at how we can minimize refactoring costs. First thing to realize is that not all database change is expensive. I was making blanket statements earlier saying, well, this is horrible, this is expensive, you've got to roll this back, and so on. But that's not quite true of everything. Generally speaking, you can add new objects with minimal cost. Adding a new object doesn't affect your existing API. Adding a new object really doesn't depend on the existing data volumes. So you're not fighting your applications, you're not fighting inertia. It's relatively safe. Adding an object is rarely going to break an application. I have yet to see an application that depends on the non-existence of table X. Oh, I've just added table X and suddenly this test fails. Oh, it's not going to happen. So it's safe. So adding new objects with each iteration is pretty safe. If that's all we do in iterations, add new things, we can do iterative development. So if we can ensure that the objects we create are right the first time, if the objects we created in the last iteration don't have to change in this iteration, we're going to save ourselves a whole load of effort. Our DBA is going to be able to sleep at night. So,
quick question on that.
Sure.
Does that not lead to a tendency to add new tables where you probably should be updating existing tables, and so you incur a technical debt?
It might do, but I think what we need to do is whenever and I say we want to get it right the first time, just adding a table isn't getting it right. I'm talking about getting the entire database design right. So we put in the tables as we need them, but we have a correct design, a sensible design. I hope I'll cover that better as we go through, but ask me again at the end if I haven't. So getting it right the first time, that's kind of tricky, isn't it? Yeah, is this even possible? No, of course it's not, but we can try it. We can do better. And I think the way we do better is if we put in some effort up front and do some big picture data modeling. Yeah, I'm getting those suspicious looks now. I'm at an Agile conference and it sounds like I'm advocating waterfall. Yeah, this is great. The lynch mob, remember where it starts? Okay, so is it Agile heresy? Well, I don't think so. And I think it's not, because if this works, it's a pragmatic approach. And I think if nothing else, Agilists are pragmatists. So, just bear with me and I will try and justify this a little more, but here's my suggested process. So, this is really key. Separate the entity relationship modeling from table design and implementation. Separate the logical model from the physical design. Logical modeling is so often missed when we're sort of caught up in the desire to just develop. You know, obviously you're going to do the physical design because you have to implement the tables, but people often miss that logical design. So it's important, and we need to make sure that we do it separately. And I think what we need to do is create a more or less complete, but not very detailed, entity relationship model. Only talking about entities and relationships. I'm getting a lot of suspicious looks still, but please, bear with me. So once we've got our ER model up front, we can do iterative table design, implementation, and model refinement. Yeah, we're not going to get it right the first time, but the less we get wrong, the less refactoring we'll have to do. So with each iteration, as we're releasing new functionality, that's when we put in the tables to support it. But we put those tables in based upon our logical model, which we have revised as we've gone on. So this is where the big questions really come in, this complete model up front idea. Obviously there's a few questions there. Well, why? And yet people do give me that look and do question my sanity when I suggest it. How can we even do this? And finally, what do we model, assuming that we believe we can? So let's take a look at that. So the why. Well, I think I've already kind of talked about that with the refactoring costs. But a good data model is going to be generalized and abstract in the right places. And I'll talk a lot more about generalization and abstraction as we go through this. But we can only do that. We can only do abstractions. We can only generalize if we've got the big picture. We can't abstract from a tiny little shoebox view of this massive world. We've got to have the big picture in order to do that. We know that major refactorings will be expensive. No one seemed to argue with the idea that database refactorings were going to be expensive. So if we implement a non-generalized model, because we've just evolved our design, and we realize later that it should be abstracted, it should be generalized, it's going to require major refactoring to get there. And I've seen this. I've seen companies where we know we want to switch to a generalized model, but we've got so much inertia, it's going to be so expensive to make the changes that it's just not an option. So that brings us on to possibly the bigger question, which is how? If the requirements are unknowable and subject to change, how can we create a complete model? And surely this is the big question. The lesson of Agile is that we are successful because we accept requirements change. And we deal with a small subset of the requirements while other requirements become clearer. If that's the case, if that's the real world case, how can we create a complete model? Surely it's just not possible. Well, I think it is. Because I think that an entity relationship model should be based on the underlying reality of the system and not on the requirements. I believe that the requirements are irrelevant to the data model. If I were to suggest to you that you should create a data model for a school timetable system, most of you could go in, give it a pretty good shot, because the domain is understood, the data entities are understood, the relationships are understood. It doesn't matter what the requirements are. It's the underlying reality that we're trying to model here. So I think we can do this. The underlying reality of most systems is knowable, even if the requirements aren't. Now, there's always going to be vague areas, there's always going to be areas of uncertainty. But for most of us, if we're building a system, we can probably know 80% of the underlying reality of it. And if we can do 80%, there's a good chance we can get our abstractions right and our generalizations right. And that's going to lead to less refactoring. So, what do we model? The last of those questions. entities and relationships only. Don't care about the attributes. I really don't care. What is, if we're doing a school timetable system, well, maybe we have a class as an entity. Well, I don't care what's in there. The only things I care about are the relationships, the foreign key relationships to other entities. When it comes time to implement that class table, we're going to know what we're going to want to store. Right now, we don't have to know that. So this upfront model that I'm advocating isn't very detailed. It's something you can probably put together for a model of 50 to 80 tables in a week. This isn't going to slow down your development process, but it can reduce the cost of refactoring dramatically. model. If we decide later that time zone is so important, and there are problems with this model because of performance, now we've got to get our time zone, we've got to go not just to the thing table but to the thing detail. And if we need time zone and gender, we've got to go to the thing detail table twice. So we may get some performance problems from this. We gain flexibility, but maybe it's going to cost us in performance. But if we later decide that an attribute really needs to be in the thing table and not as a dynamic attribute, we can add it. Because an addition to that thing table is less expensive than most other refactoring. It's an addition. So it's a cheap refactoring. So you don't necessarily have to get this right straight up, but this is a flexible model that allows us to not worry about attributes. Sort of generalizations I was talking about. Have a quick look at some abstractions. Well, what am I really talking about? An abstract entity is one which can represent a number of different, but hopefully similar things. We saw that party attribute, that abstract type earlier. And that had software agents, persons and organizations, abstractions. So the party is an abstraction. Here's an extremely abstracted data model. Thing, related thing, and relationship type. Now this is kind of insane, but you can implement anything with this model. I actually saw a product from IBM about 20 years ago that used this model, or more or less. I don't think it actually recorded the relationship type explicitly. And it was a diary, to-do list, address book, everything. Just with the thing and the related thing tables. Amazing piece of work. Don't think it ever solved. Now I'm not advocating necessarily doing this and saying, okay, well that's my database design. Yeah, it could, but that's kind of just stupid. But I actually use this model quite a lot for where I'm working now. We have items which are products, and products can be made of other products, products can be packaged in other products, products can be related to other products, can be substitutions. This model deals with all of that. So we have our item table, our related item, and the type of relationship. And by just putting that in there up front, when I'm doing the high-level data modeling, I know that I've covered pretty much all the basics, and I don't really have to think about it too much. And it's not going to have to change. This is the more useful model, and this is probably my favorite one, party role relationship. This is from, at least from the first version of Len Silverstone's book. A party in Len's view is a person or an organization, and they have relationships with each other. So a person might be, a particular person might be a merchant, another one might be a customer, and we can have a relationship of customer of merchant. The relationship type has two roles because there are two participants in the relationship. So the first role will be customer, the second one will be merchant, or vice versa. And this is a really flexible model. You can pretty much represent any relationship between business partners, people with this model. It does have an issue with multidimensionality of relationships, but if you need to know about that, you can hire me as a consultant. Whoa. Oh yeah. So the value of an abstract entity is really most apparent when you have other entities referencing it. And here we have, based on the party role relationship model, we have an accounting model. So a party up there in the top left, we now have, with this, a full accounting model. So every party any party can have an account or a number of accounts at different times. And transactions consist of movements, possibly a set of movements of funds from one account to another. Because what we have here, we actually have the transaction part, we have the transfer going from one account to another. We've got double entry bookkeeping, and we haven't violated third normal form. I think this is one of the most elegant models I've ever seen, and it makes me wonder why Oracle Financials has 2,000 tables. This does everything you really need for an accounting system. Okay, all the metadata stuff can go somewhere else. I guess there's 1,900 tables. I don't know. So abstractions are pretty powerful. But there's a real problem with them, which is you can only abstract similar things into a single entity if you know what all those similar things are. If if you implement each thing one at a time, if you only know about one thing at a time, you can't abstract it. So if you've got customers, vendors, agents, examiners, you may be able to abstract those into a parties table. But if you've only got customers, the only thing you know about, because the only requirement you take a notice of is the requirement to deal with customers, well, why would you create an abstract entity to deal just with customers? Doesn't make any sense. So, if we were to build our system naively, one table at a time, well, we start off with our client table, and then maybe we get our vendors and our customers, and we have business partners, and then we say, okay, well, now it's time to add accounts. Well, what are the foreign key relationships from accounts to this thing going to look like? It's going to be a nightmare. You're going to have either link entities or multiple account entities, or you're going to think, oh, maybe we should have abstracted this. It's horribly ugly. And it's ugly, or it's going to be ugly, because we didn't do the modeling up front. That week or two I talked about earlier of doing that entity relationship modeling, that very high level view, if we'd done that up front, we wouldn't be in this situation. So if you don't model the big picture up front, once you actually know enough to understand that you really want party role relationship or something similar, all of that inertia, all of that lack of source code, the need to coordinate with your applications on how many different databases, all of that is going to make your journey very expensive and difficult. So yeah, you can get there from here, but it's not going to be pleasant. So, I gave you some Dogma earlier. I thought I'd finish off with some Pragma. Don't invent when you can copy. Go out there and get Len's work. Copy the stuff from Len Silverstone. Copy the stuff from me if you like. Use standard models. Yeah, Len's models are a good thing. There's loads of stuff online. There are actually websites devoted to standard models. Who knew? Reuse models you've used before. Now, if you've done something successfully, reuse it. Well, why wouldn't you? And you can think about reusing it even before you started modeling, pretty much. When I started with my current company, I pretty much knew that I wanted to use party role relationship because I knew it was good. It was going to give me a good accounting model. So, where's the Agile go? Well, we kind of talked about upfront modeling. You should remember we're still talking about Agile. We don't have to implement it all at once. That's really the most critical thing about this. We do the upfront model so that when we do have to implement, we know what we're going to implement. We can do iterative development from an upfront model. Not a problem. I'm going to implement these 3 tables this week. The other thing is we don't have to get it completely correct. We can do iterative refinement. Yeah, the less correct we get it, the more we're going to pay in refactoring. But you're not going to get it right first time. You know that. So, Agile implementation, this is what we do. We revisit and we refine the model at the start of each iteration. That model up on the wall. We look at it, we see what we've got wrong. Pencil it in, paste up a new copy. Make explicit documented decisions on all of those details you left for later. So when you're creating the tables and you've gone from your entities with subtypes, explain somewhere why you've chosen a particular implementation. Put it in comments in your create table script, do whatever, but document it somewhere. Because someone's going to ask you eventually. And yeah, the things we're talking about, those implementations of subtypes, the removal of explicit join entities from my model in Dogma, and obviously additional stuff you just didn't know about. And then yeah, just do it. And if that isn't an Agile attitude, I don't know what is. Just get out there and do it. So, summary. Model the real world. Forget those requirements. Model the real world. Of course, it does assume that you understand the real world. Model in as little detail as possible. Design for change. Use those flexible models. Use standard models. Yeah. The things that Len Silverstone has done, they're incredibly detailed, way too detailed in my view, but they're going to work. He's researched the stuff. He knows what he's talking about. And model, when you are modeling, make make the need for future design decisions explicit. You know, if you have to just put big asterisks on the model and say, we need to think about this, do it. But you can also use the model and Dogma approach. And then refine and implement iteratively. So there's some suggested reading there. I should point out that I actually hate that last book. Refactoring databases. Evolutionary database design, well, of course I hate it. I just think it's the wrong approach. But on the other hand, he does explain very well how to refactor databases. If you have to buy this book, hide it. Don't put it on your bookshelf, because you know what will happen. If it's on your bookshelf, your co-workers will see it, your boss will see it, and they will immediately assume that refactoring is something you can do cheaply and easily, and they will ask you to do it. So hide it. Yeah. Don't let anyone see it, but yeah, it's actually a good book. And if you need a book on modeling, Peter Demansky and Philip Irvine's book is very good. Any more questions? Did I answer your question from earlier?
Yeah, I think so. Can I ask another one?
Please.
So if you're building a greenfield application, though, like a lot of the problems you identified earlier on, like data, they kind of go away, do they not? You don't have to worry so much about data, and if it is greenfield, you know.
Oh, you mean in terms of, sorry.
Rather than generating patches, you can just regenerate the whole thing from scratch.
Absolutely. When you're starting a fresh database design, although you're still dealing with patches, you're dealing with a database creation script, starting from null state to create state. Yeah, you can throw away your database and start again every time, up until you first release. At that point, you're back into the problems, and at that point you start encountering inertia. But yeah, for your very first database, you have no inertia, and your start state for your database creation scripts is a null state, so you don't have a problem with compatibility. So yeah, great. Yeah, the very first stages of database development, they're great. They're the days that DBAs have a really good time because we're doing all the creative stuff and not having to do all the administrative stuff.
I think the problem is that we don't know what real world is, until our client sees it, and he doesn't see it until our first release. So it's vicious circle.
Well, but the world that your client is operating in is knowable, and generally they know it.
To a certain extent.
Yeah, there are issues about process that they don't know. But if you're dealing with real estate or whatever, well, we've all got a fairly good understanding of what real estate really means anyway. And we can go in and we can talk terminology. And I guess the domain modeling people talk about consistent terminology. Once you understand the terminology, you can probably build a good data model. And yeah, it's not going to be 100%, but if you can make it 80 or 90%, you're going to be ahead of the game. It's good enough. Yeah? Oh.
In our organization, I know what the opinion would be from the EAs and DBAs, but what's your opinion on XML
I kind of hate it because it's opaque. It's a blob. As far as I'm concerned, XML in a database is a blob, and you should treat it as a blob. That means you can't index it, you can't search on it. You know, if you really want to be searching on those things, then you probably should have a secondary index associated with that blob. But that's a personal prejudice as much as anything. I'm no expert.
Do you see a place where it has used?
XML, yeah. XML in databases, yeah. It's kind of tricky. I'm a big fan of relational databases because they have a good mathematical foundation, and the relational theory is great. You can prove things about databases. As soon as you start dealing with blobs, it becomes a whole lot harder to know what you're dealing with. So I don't like manipulating XML in SQL. I think that's probably my bottom line. Yeah. What's beyond that? Store what you like in the database, but try to manipulate XML. SQL is the wrong tool.
Yeah, like in real world, a lot of times we already stuck in that bad model. So is it better to continue the top journey, or is it better to scrap and start a new one?
I can't answer that. The question is, in the real world, you're already halfway there.
Yeah.
And you're already halfway to the problem. I can't tell you what's going to be cheaper. Throw it away and start again, or just live with it. The problem with just living with it, it gets worse and worse and worse. So if you can see abstractions you can put in, put them in as early as possible. If, when you look at that, you decide it's uneconomic, get used to living with it. Yeah, I wish I had answers. I really don't. Anyone else? Cool. Did I convince you that it's expensive? Okay, good.